Alright, today class we're going to talk about L'Hopital's rule. And there's a lot of uses of L'Hopital's rule, and this is particular one of them. Okay, so if I substitute 0 into this limit, I get 0 to the 0. Oops. 0 to the 0, which is one of the 7 indeterminate forms that you're supposed to know. Alright, now it just so happens that L'Hopital's rule only works for 2 of them. 0 over 0 or infinity over infinity. So notice that this is not one of those 2 forms. So we're going to have to do a little bit of algebra here to make it into one of those 2 forms. And the first thing we're going to have to do is we're going to have to change the base. And this happens with all of the ones that are the exponential indeterminate forms. And remember, the other 2 are 1 to the infinity and infinity to the 0. So those are all indeterminate forms. All right, so first thing, we're going to have to use the fact that a to the x is the same thing as e to the x natural log of a. So that's the change of base formula for exponential functions. And so we're going to take this and we're going to treat the a is going to be the sine of x and the x is going to be the x. So we're going to write it like this, and I'll explain why in a second. So we're going to say e to the limit as x goes to 0 plus, okay, and the x stays x, and we take the natural log of the base, so that's natural log of sine, okay? So that's what our limit is now going to be equal to. And now if I substitute 0 in, I have 0, and then log of sine of 0 is 0, so log of 0, which is the limit as x approaches that from the right-hand side, is going to be negative infinity. So it's 0 times negative infinity. And 0 times infinity is another indeterminate form, but unfortunately not 0 over 0 or infinity over infinity. All right? And let me back up just a second and say the reason we can put this limit inside, there's a theorem out there that says that if you have a limit as x approaches a of f of g of x and f is continuous, then that's f of the limit as x approaches a of g of x. So we're able to move that limit on up inside, and we're just really operating L'Hopital's rule on the exponent. All right. So we need to divide by 1 over one of these 2 things, because 1 over 1 over something is just the something. Never, ever, ever do that with a log unless you have 2 logs. You have to do it with one of them. So what we're gonna do here is we're gonna leave natural log of sine of x in the numerator, and the denominator is going to be 1 over x. And now if we substitute 0 in this time, once again the top is going to be negative infinity, and the limit as x approaches 0 from the right of 1 over x, well it explodes, so that's going to be infinity. So voila, we have to speak French because L'Hopital is French. We have an indeterminate form that we can use L'Hopital's rule on. Alright, so now on problems like these that are super, super long, it's probably a good idea if you have to go back and find a mistake that you have some documentation. So I'm writing LR here to denote that we're taking the L'Hopital's rule, we're actually using L'Hopital's rule here. Okay, notice all the stuff we've done up to here is just algebra. So the simpler L'Hopital's rule problems, you probably don't need to do that. Alright, so the derivative of log of sine, that's going to be 1 over sine. And then the derivative of sine's cosine, you have to use the chain rule. Okay? And the derivative of 1 over x is negative 1 over x squared. Okay? Alright, so let me simplify this. So usually after you do that step and you have a double fraction, you need to probably take a step to rewrite it. In dealing with trig, I can tell you that a nice thing to do is to change everything to sines and cosines at this stage. Alright, so we're going to have negative x squared cosine x over sine of x. Okay? We substitute 0 into that, we get 0 over 0, so it's still in an indeterminate form. Alright? So we're going to take L'Hopital's rule again. So let me come over here to do that. All right, so the derivative of negative x squared cosine of x, that's going to be the product rule. So the derivative of x squared is going to be negative 2x, and then cosine, and then the derivative of cosine is going to be negative sine, so it'll be plus x squared sine x. This is e to the limit as x approaches 0 plus of negative 2x cosine x plus x squared sine of x. And then the derivative of sine is just cosine. Okay? And it's always good when you see cosine by itself in the denominator, because that means you no longer have an indeterminate form. So when you substitute 0 into this, we get 0 here and 0 there, but 1 there. So this is now 0 over 1 and no longer in an indeterminate form. That means we get e to the 0, and that's 1. All right, just a couple things to sort of remind you of. Every time you have one of these exponential things, you're going to have to use this change of base. I also suggest writing the e every time. That if you look in some books, they'll just forget about the e and they'll just calculate this limit and then get an answer and substitute it back. What I've noticed with students in the past is when they do that, they end up saying the limit's 0 and forgetting to substitute it back in and say the limit's really e to the 0, which is 1. So I'm going to suggest that you copy that e every single time in order to not make that mistake. Lastly, go ahead and document where you've used LHospitals Rule in case you make a mistake. It's real common to say, you know, this is a complicated problem, you get to this stage, and you forget the chain rule. And then you don't know what your mistake is when you're looking in the answer, as it's not the same as the one in the back. So yeah, this is one of those things where, you know, you probably need to, you know, document stuff a little bit better, because these problems are, especially with trig, they do get a little bit on the long side. All right, doodles.